Jai Hind, myself Nidhi Singh, Assistant Professor in Electrical and Electronics Engineering Department from AKGEC Engineering College. Today I am going to discuss a topic from Fundamentals of Electrical Engineering, and I am discussing mesh analysis. This is a topic from Unit 1. So, what is mesh analysis? The mesh current method is a network analysis technique where mesh, or we can say a loop, current directions are assigned, and then Kirchhoff's voltage law and Ohm's law are applied systematically to solve for the unknown currents and voltages. So there are some points which we should remember for loop analysis. So while assuming loop current, make sure that at least one loop current links with every element, and no two loops should be identical, and choose minimum number of loop current, and convert current source if present into their equivalent voltage source for loop analysis whenever possible. And if current in a particular branch is required, then try to choose loop current in such a way that only one loop current links with that branch. Now these are the steps which we should follow for solving the loop analysis. So the step 1 is choose various loop. First, we have to identify the number of loops, or we can say mesh. So there is a difference between mesh and loop. The mesh is the smallest loop, right? So, and the step 2, so we have to identify the number of meshes. So step 2, show the various loop currents and the polarities of associated voltage drops. And then step 3, before applying KVL, look for any current source, because we can't write loop equation including the current source. So analyze the branch consisting current source independently and express the current source value in terms of assumed loop currents, and repeat this for all the current sources. And then after step 3, apply KVL to those loops which do not include any current source, and a loop cannot be defined through current source from KVL point of view. And here follow the sign convention. Then step 5, solve the equations obtained from step 3 and 4, and we can obtain the required unknowns, right? So now how we can solve the loop mesh analysis? So here I am taking one circuit. Right? So suppose this is V1, this is V2, here this is R1, this is R2, and this is R3. Now we have to apply the mesh analysis here. So the first step is to identify the number of meshes, right? So I am just naming all the nodes A, B, C, D, E, and F, right? So there are two meshes here. So mesh 1 is A, B, E, F, A, and mesh 2 is B, C, D, E, B. These are the two meshes. So the first step is to identify the number of meshes. So we have identified two meshes, mesh 1 and mesh 2. And after identifying, we will consider the loop currents here, right? So loop current can be considered in clockwise direction or in anti-clockwise direction. In either way, you can assume in clockwise direction or anti-clockwise direction. So here I am assuming the current direction, this loop current direction is clockwise. So I have assumed this loop current is I1, which is in clockwise direction. Again, I have assumed here the current direction is clockwise, which is I2. After assuming this current direction, now you can assign the polarities here, right? So I'm assigning the polarities here. So according to my current direction, current will flow from higher potential to lower potential. So this will be plus, minus, this will be plus, minus. And now for the next loop, this will be plus, minus, and this will be plus, minus, right? Now, the next step is to write the equation. So now if I will write the equation from here, if I will start, the current flowing in this R1 resistance is I1 and we are going towards the drop. So drop we will take as minus, right? So if I want to write the equation, I will write for, if I am writing equation for mesh 1, right? I am applying KVL in mesh 1. So I can write this equation, this will be equal to minus I1 R1. Now again I am going to this R2 and here you can see that in R2, two currents are flowing, that is I1 and I2. And the direction of I1 is from B to E and direction of I2 is from E to B. It means that both the current is flowing in opposite direction. So if I am writing equation for this loop, you will write I1 minus I2. The current flowing in this R2 is I1 minus I2. So you will write minus, the current flowing is I1 minus I2 and the resistance is R2, right? And now coming to this voltage, so I am going towards the right. So I will write plus V1 and according to KVL, this will be equal to 0. So this is the equation for mesh 1. Now writing equation for mesh 2, right? So in this R3, you can see that I2 current is flowing and I am going towards the drop. So you will write minus I2 R3 and now coming this voltage source and I am going towards the rise, right? So I will write plus V2 and again this R2, when I am coming to the R2, again this I2 and I1, these both currents are flowing in this R2 and these both currents are flowing in opposite direction, right? And as now I am writing for this equation for the loop 2, so now I will write I2 minus I1. So here I write minus, the resistance is R2, now the current is I2 minus I1 and this is equal to 0. According to KVL, this will be equal to 0. So after solving this equation, if the value of V2, V1 and all these resistance are given, so unknown, the unknown is I1 and I2, so you can easily find these two unknown variables by solving these two equations. So you can find, so I1 and I2 are the loop current. So this I1 and I2 is loop current, and if you want to find the branch current, like suppose if you want to find the value of current in branch BE. So branch BE, in this branch BE, what current is flowing? Suppose if I1 is greater than I2, so in branch BE, the current flowing is I1 minus I2, right? And the direction will be according to I1, that is downward, that is from B to E. The direction of current will be from B to E, right? So this is how we can write the equation and we can follow this step to solve the mesh analysis question. So now here we have, in this question, we have to calculate the current through 6 ohm resistance using loop analysis. So the first step is to identify the number of meshes, right? And after identifying the number of meshes, we will assign the loop current. And according to that, we will assign the polarity on the resistance. So here we can see that there are total 3 meshes are there. So if we draw this circuit and we have assigned the loop current, that is I1, I2 and I3. So 3 currents, we have assigned the 3 currents here. So now this is mesh 1. This is mesh 1. This is mesh 2 and this is mesh 3. So if we want to write the equation for mesh 1, so let's write the equation for mesh 1. So starting from here, in 2 ohm resistance, we can see the current flowing is I1. So we can write, so we can write here minus 2 I1. Then coming to the 4 ohm, again here we can see that I1 and I2, they both are flowing, but they are flowing in the opposite direction. So we will write I1 minus I2, right? So minus 4, we are going towards the drop, right? In this loop, we are going towards the drop. So we will write minus 4 and I will write I1 minus I2 And now coming to the voltage source, here we can see we are going towards the rise. So we will write plus 10 and this is equal to 0. According to KVL, this will be equal to 0. So this is equation for mesh 1. Then we will write, apply KVL in mesh 2. So applying KVL in mesh 2, here we can see that in 1 ohm resistance, I2 current is flowing, and as we are going towards the drop, we can write minus I2, that is I2 into 1. Then in 6 ohm, again here we can see that I2 as well as I3, they both are flowing, but they are flowing in opposite direction. And as we are writing the equation for second loop, so we will write I2 minus I3. So, and as we are going towards the drop, we will write minus 6 and current will be I2 minus I3. And now again we are going towards the 4 ohm and we are going towards the drop. So this will be minus 4 and the current will be I2. Now here we will write I2 minus I1. And in this loop, there are 3 elements, 3 resistance are there, and we have covered all the elements here, and this will be equal to 0. So this is equation for mesh 2. Similarly, we can write equation for mesh 3. So here we can see that in this 4 ohm, this is minus 4 I3. Here in 20 volt, we are going towards the drop, so minus 20. And 6 ohm, this we will write minus 6. And current is I3 minus I2. So we will write I3 minus I2 and this is equal to 0. So these are 3 equations. So these are 3 equations for these 3 mesh. Sorry. So after solving these 3 equations, we can find value of I1, I2 and I3. And now in this equation, so these are the loop current. I1, I2, I3 are the loop current. And in question, we have to find current in 6 ohm resistance. That is in this branch. That is in branch CF. We required the current flowing in this 6 ohm resistance. So if we know the value of I2 and I3, we can find the value of current flowing in 6 ohm resistance, because the current flowing in this 6 ohm resistance is the difference of this I2 and I3. So if we solve, we will get I2 is equal to minus 1.1267 and I3 is equal to minus 2.676. So answer is coming in negative. It means the direction which we have assumed is not right. The direction of current is actually anti-clockwise, but we have assumed clockwise. So that's not the problem. You can assume in any direction. The minus sign itself, it is telling that your current direction is anti-clockwise direction. So the current flowing in 6 ohm resistance will be I2 minus I3. So if you subtract this, you will get 1.5493 and the direction will be from C to F, right? So this is the required answer. This is how you can solve this question. Now coming to the concept of super mesh. So what is this super mesh? If there exists a current source in any of the branch of the network, then loop cannot be defined through the current source, as drop across the current source is unknown from the KVL point of view. So we can't write the equation by considering the current source. So the loop existing around the current source, which is common to the two loop, is called super mesh here. So if this is a question and we want to solve this, we have to write the equation. So we can't write equation for these two meshes, right? A, B, E, F, A, or we can't write the equation for B, C, D, E, B, because in this both the meshes, what is there? The current source is there, and we can't write loop equation by considering the this current source, right? So how we will solve this question? We will write the equation for this branch BE and the loop equation. Now which loop we will consider, right? Which loop we will consider? We will consider this loop. We will consider this loop. It means we will write equation for A, B, C, D, E, F, A, and this is called super mesh, right? And this is the super mesh. So now here, this is the question for the super mesh. So here we have to find the current through branch AB. using mesh analysis. So here you can see that the 5 ampere current source is here. The one way is that if it is you can easily convert this current source into the voltage source, then you can convert it, but it is not always possible to convert. Like in this example, this 5 ampere source cannot be converted into voltage source because there is no parallel resistance against this 5 ampere current source, right? So we can't do the source transformation. So how we will solve this question? So for solving this mesh analysis, the first step is to identify the number of meshes, right? So first we will identify the number of meshes. So we can see that there are 3 meshes, right? So there are 3 meshes. The first step we have done, we have identified the number of meshes. The second step, we will give the current. We will assume the current. And then when, now how to write the equation? We can't write the equation for this loop, right? And we can't write the equation for this loop because here we can see that there is a current source. But we can write the equation for this loop, right? We can write easily equation for this loop. So which loop we will consider to write the equation? We will write the equation for A, B, C, D, A, right? We will write equation for this. And the second equation will come from the super mesh. So which is the super mesh here? Now, here, what is the super mesh here? Here we can see the super mesh. This is the super mesh. So super mesh is G, H, A, D, E, F, G. This is super mesh, right? This is super mesh. G, H, A, D, E, F, G. So 2 equations, we will get 2 equations from this, and the third equation we will get by solving this branch. So first we will write equation for A, B, C, D, A. So here for this one, if I write equation for this one, suppose this is first mesh and this is second mesh. So if the equation for this will be minus 3 I3, then 50 volt, right? 50 volt. So I am going towards the drop. So I will write minus 50 and now 6 ohm. So minus 6 as I am going towards the drop. So minus 6, and here you can see that current I3 and I2, right? Current I3 and I2, they are flowing, but they are flowing in opposite direction. So here you can write this will be equal to I3 minus I2, and this is equal to 0. So this is for equation, and now for equation for this super mesh. So equation for this super mesh, you can write in this 5 ohm, according to my convention, the current flowing in this 5 ohm is I1. So this I will write minus 5 I1. Now coming to the 2 ohm, because I am considering this whole loop. So in 2 ohm, which current is flowing? I2 current is flowing. So I will write minus 2 I2. Now coming to the 6 ohm, minus 6 I2 minus I3. Now I will write I2 minus I3. And now coming to the 60 volt, and I'm going towards the right, so I will write plus 60, and this is equal to 0. So I have written two equations for this loop. Now the third equation will come from this branch HE. So for this branch HE, you can write this 5 ampere, right? You know the difference of this current will be equal to 5 ampere. So I2 is in direction of this 5 ampere. So I will write I2 minus I1 is equal to. So this branch HE I can write I2 minus I1. This is equal to 5 ampere. So these are my 3 equations, and they are 3 unknown variables, that is I1, I2 and I3. So I can find the value of I1, I2 and I3. And but according to this question, we have to find the current in branch AB. That is in 3 ohm. It means the answer will be I3. So the current I3, what will be the value of I3? We will find after solving these equations. So here we can see, after solving this equation, we will get I3 is equal to minus 1.72 A3. It means the direction of current we have assumed from A to B, but actually it is from B to A. So this is the value of current which is flowing through the branch AB, that is 1.7283, and the direction is from B to A. So this is how we can solve the super mesh question. So now next is using mesh current method, determine Ix in the following circuit. So here in this question you can see that the source transformation is possible here, but the problem is this branch, if you do the source transformation, this branch will be consumed in the source transformation, right? So you can solve this question both the way, but first we will solve this question without source transformation. So the first thing is we will consider the various loops here. So I1, I2 and I3 here, and we can write the equation for A, B, G, H, A. We will write the equation for A, B, G, H, A, and then we will write the equation for this super mesh, that is B, C, D, E, F, G, B, right? B, C, D, E, F, G, B. We will write equation for these two loops, and we will solve for this branch, that is branch CF. So if we write the equation for this AB, GHA, so this AB, GHA, what will be the equation? Equation will be minus 3 I1, then minus, this is 1 ohm resistance, here we have a 1 ohm resistance, this is I1 minus I2, and plus 2, this will be equal to 0. So this is the equation for this loop. The next equation for this super mesh, right? So for this super mesh, here we can see this, we have 2 ohm, so minus 2 I3 plus this 5 volt. And now coming to the 1 ohm, so minus 1, and the current is I2 minus I1. So we will write I2 minus I1, and this will be equal to 0. And now writing equation for this CF branch. So in CF branch we can see that I3 minus I2 will be equal to 2 ampere, right? So by solving these three equations, we will get value of I1, I2 and I3, and Ix will be equal to Ix, current flowing in this one, will be equal to I1 minus I2 or I2 minus I1, which. So here we can see, so after solving all the equation, we will get I1 is equal to 0.6363, I2 is equal to 0.5454, and I3 is equal to 2.5454. So Ix will be I1 minus I2, which is coming 0.0909 ampere. So this is the way we can solve this question without source transformation. Now suppose if you want to apply the source transformation. So if you want to apply the source transformation, this circuit will become plus minus here, and you are converting this 2 ampere and 1 ohm. So this 1 ohm, and here the voltage source will come. This will be the positive, this will be negative, and the value will be 2 volt, and minus plus, this is 5 volt, 2 ohm, this is 3 ohm, this is 2 volt, right? So if you solve this now after doing the source transformation, the circuit will look like this. And if you solve this, now assume I1 here and assume I2 here, right? So if you solve this, you will get I1 will be equal to 0.6363 ampere, and I2 will be equal to 2.5454 ampere, right? And we have to find the value of Ix according to this circuit. Now again, now I know the I1 is 0.6363 6363, right? And the value of I2 is 2.5454, right? Sorry, the direction will be like this. Right? So the direction will be like this. As my values are coming positive, so direction will be like this. Now again, what I will do, I will again do the source transformation for this branch. So if I will do the source transformation for this branch, again I will come to this circuit. And now I know the current flowing in this 3 ohm. So what is the current flowing in this 3 ohm? This is equal to 0.6363, right? And I know the current flowing in this 2 ohm. So what is the value of current flowing in this 2 ohm? This will be 2.5454 ampere, right? Now, what will be the value of current which is flowing through this IX? So this current 0.6363, this is coming in IX and some current is going in this branch, right? And this current plus this current is coming 2.5454, right? So 2 ampere is coming from here. So what current will be coming from here? That you will get 2.5454. Obviously, this will be 0.5454 ampere, right? And this 0.6363 is getting divided in IX and 0.5454. So what will be the value of IX? So IX will be equal to this current minus this current. So if you will subtract, you will see that this current IX is coming 0.0909 ampere, right? So this question you can solve in both the way, by source transformation also and without source transformation also. So without source transformation, as I have discussed earlier, but if you are solving this question with source transformation, the problem in this question is that the branch which you are using in source transformation, in that branch, according to question, you have to find current in that branch only, right? So if you do the source transformation, this branch is now dissolved. So again, if you are using the source transformation, so you have to apply this step, like you have to divide the current and see what current is flowing this in IX. So according to this circuit, you have to give the current which is flowing in this 1 ohm resistance, right? So what we have done, we have calculated the value of I1 and I2, and now I know the current flowing in this 3 ohm and the direction of this current, and now I also know the current flowing in this 2 ohm and the direction of the current. So again, what I am doing, again I am doing the source transformation of this voltage source, and now I am coming back to my previous circuit. So in this, what I have done, I have divided the current, and now I have seen that IX is coming 0.0909, and from previous method also we are getting the same result. So this is how you can solve the equation, solve the questions related to the super mesh. So these are the references which I have referred for this lecture. Jai Hind. Thank you very much.